Hi there, I Neeraj Yadav welcomes you on my YouTube channel. Today I am going to discuss the working of 4-stroke and 2-stroke engine. Before going to move on, spare a second to press like, share and subscribe in advance. Let's go to understand the working of 4-stroke and 2-stroke engine. The thermodynamic cycle of an engine consists 4 processes: suction, compression, power and exhaust. Here P stands for pressure, V stands for volume, and the blue line shows the P ATM, P atmospheric pressure. This is P ATM. Then the process 0 to 1 represents the suction. Then the process 1 to 2 represents the reversible adiabatic compression. Process 2 to 3 represents the constant volume heat addition. Then process process 3 to 4 is a reversible adiabatic expansion process. Process 4 to 5 is a constant volume heat rejection process, and process 5 to 0 is a expansion process. So 0 to 1 is a suction process, 1 to 2 is a compression process, 3 to 4 is a expansion process, and 5 to 0 is a exhaust process on a PV diagram. Let's understand the working on a piston cylinder. The first diagram shows the suction stroke of the engine. During the suction stroke, only petrol and air mixtures come inside the cylinder through the inlet valve. Only inlet valve is open during the suction stroke, and the exhaust valve is closed. During a suction stroke, mixture of air and petrol comes inside the cylinder and the piston moving from TDC to BDC. After in a compression stroke, the piston moves from BDC to TDC. During the compression stroke, both inlet and exhaust valves are closed. The mixture of air and petrol compressed results high pressure and temperature at the end of the compression of the mixture. Then expansion stroke, before starting expansion stroke or at the end of compression stroke, the spark is produced by the spark plug. This process 2 to 3 represents on a PV diagram. Here this is the constant volume heat addition. The heat is added with the help of spark plug. Then this is the process suction 0 1, and this is the process 1 to 2, and this is the process 2 to 3, which is at the end of the compression stroke. After heat addition, the gases expand from TDC to BDC. This is shown in a process 3 to 4 on a PV cycle. Then the exhaust stroke. During exhaust stroke, piston move from BDC to TDC. Only exhaust valve is open during this stroke, which allows the exhaust gases or burnt gases to move outside the cylinder to discharge into the atmosphere through the 5 to 1. The process 4 to 1 and 5 1 completed in a single stroke. The 4 to 5 and 5 to 1 comes in a single stroke. In case of diesel engine, the thermodynamic cycle of a diesel engine is P stand for pressure, V stand for volume. Again, the blue line shows the P ATM. This is P ATM. ATM stand for atmospheric pressure. And process 0 to 1 is the suction process. 0 to 1 is a suction process. In a suction, only air is allowed to come inside the cylinder, and piston moving from TDC to BDC, and piston moving from TDC to BDC, and only air comes inside the cylinder. This air is compressed reversible adiabatically through 1 to 2. 1 to 2 is a compression process. This is a compression process. 1 to 2 reversible adiabatic compression is here. This is process 1 to 2. Then heat is added at a constant pressure. 2 to 3 is a heat addition. Heat is added at a constant pressure, Q in. At the end of the at the end of the compression stroke, heat is added, means fuel is injected. This is a fuel injector which inject the fuel over the hot gases. After the compression, the temperature of air and pressure become high. Over the high temperature pressure gases, the fuel is injected by the injector. Due to high temperature of air, the fuel is burned at a constant pressure. After burning, these gases is going to expand along the line 3 to 4. This is 3 to 4 process is a reversible adiabatic expansion process. Then 4 to 5 is a heat rejection process, and 5 to 0 is a exhaust process. The power stroke represented by 3 to 4. Here this is a power stroke represented by 3 to 4, and 4 5 and 5 1 represented by a exhaust stroke. During exhaust stroke, only exhaust valve is opened to allow the burned gases to move outside from the engine and discharge these gases into the atmosphere. Then the valve timing diagram. The theoretical valve timing diagram shows the suction valve is open at point A, which is at a TDC, point A at a TDC point, and the suction valve is inlet valve is closed at a point B, and the curve AB shows the suction stroke. From point B, compression is started and compression is end at a point C. This is a point C. This is point A. A to B is a suction, BC is a compression. At a point B, heat is added with the help of spark. After the heat addition, gases is going to expand from C to D, and here the exhaust valve is open. The gases moves out of cylinder, and at a point E, exhaust valve is closed. Point A is a point where inlet valve is open, and point B is a point where inlet valve is closed, and C is a point where spark is produced by the spark plug. This is the ideal valve timing diagram of a 4-stroke SI engine. The real engine or actual valve diagram is differ from the ideal engine. The point A shows the some degree before TDC. Say this is about a 10 degree or a 15 degree. This is a 10 degree before TDC. Inlet valve open. This is inlet valve open at a point A 10 degree before TDC. And this is a inlet valve close about a 25 degree after BDC, 25 degree after BDC. And the process A to B, this curve A to B represents the suction. At a point of B, this is point A, this is point B. At point B, compression is started and it will continue up to point. This uh, from point B, the compression is started, and during a compression at a point C, a spark is produced with the help of a spark plug. The fuel is the mixture of air and fuel is start burning during this process. This is angle is about a 25 degree before TDC. And from point C, expansion is started from point C and it till continues up to a point D. At a point D, exhaust valve is open, which is about a 35 degree before BDC. This is the exhaust valve open, and exhaust valve is closed after 10 degree of TDC. This angle is very according to speed of the engine. This is the range of angles for a low speed engine to high speed engine. Low speed engine to high speed engine. In this range, we have to select the angle on the basis of experimental analysis or a numerical analysis. So this angle is a variable according to the engines, and it is decided by the manufacturer. Next is a valve timing diagram of 4-stroke CI engine. The ideal valve timing diagram of a CI engine is same as a petrol engine. Only difference is that in case of spark plug, fuel injector is used to spray the fuel over the hot gases. This is the actual valve timing diagram. Point A is a start of the suction. This is inlet valve. This shows the position of inlet valve open, which is about a 25 degree before TDC and suction, and this is this is about a 50 or 45 degree or 50 degree after BDC. So this is point A and this is point B, shows the suction. From point B, compression is started, and during a compression, the fuel is injected over hot gases and expansion is started. This is point C. After expansion, this is point C. Expansion is started at point C and it will continue up to a point D, which is a 45 degree before BDC, and the exhaust was closed about 10 degree to 15 degree after TDC, and this is represented by a point E. And this is the angle, and again the angle is in range according to low speed engine to high speed engine. This is low speed engine. The range is shows the low speed engine to high speed engine. Next is the working of two-stroke engine. The two-stroke petrol engine shown here. The first diagram shows the compression stroke. During a compression stroke, at this position, exhaust port and transfer ports are closed. Only suction port is open, which allows to inhale the air fuel mixture. This is air plus fuel mixture comes inside the crankcase. This is air fuel mixture comes inside the crankcase. This is crank case. and this is suction stroke and piston moving from TDC to BDC. And this is the part, this is called a deflector. The 4-stroke engine piston is a flat face, and the 2-stroke piston is a deflected piston. This is for a 2-stroke engine, and this is for a 4-stroke engine. At the end of a compression stroke, the spark is produces, the hot gases is going to expand and piston move from TDC to BDC. This is the ports, this is the exhaust port is open as well as transfer port is open. The exhaust port allow to exhaust the burned gases out of the cylinder, and transfer port is allowed to send the fresh mixture inside the combustion chamber for the next cycle. Here this is a 2-stroke engine for a diesel engine. All the process are same, only instead of spark plug, fuel injector is used, and only air is inducted during a suction stroke. Air is compressed at a high temperature, fuel is injected. This is a fuel injector. The fuel is sprayed over the hot air. The fuel burn and piston move from TDC to BDC, and from exhaust stroke the burn gases move out of from the cylinder, and from the transfer port only air is inducted in a combustion chamber. The valve timing for a 2-stroke and 4-stroke engine. This is point A, TDC, this is point A, this is point B, this is point C, this is point D, this is point F, this is point G, and this is point H. The inlet during a from point C, the inlet port is open. The C to D, C to F. At a C, inlet port is open, and at a F, inlet port is closed. So CF is a suction process. CF is a suction process. Plus, during a suction, the compression start from D to A. D to A represents the compression of the mixture or air in case of diesel engine. So D to A, so this process is a compression process, and CF represent the suction. During a compression at a point H, ignition start with the help of a spark plug. Spark is produces, or with the help of diesel fuel injector, diesel is sprayed over the hot air to start the ignition. From A, expansion is started, and during expansion at a point B, exhaust port is open. A to D is a expansion. At a point B, exhaust port is open, and at point G, exhaust port is closed. So B to G represents the exhaust process. B to G represents the exhaust process. During a B to G process, exhaust port is open and exhaust port is closed from here. This is the reason where both the valve is open. F, and we have seen C2D. C2F is a region where both inlet port and exhaust port are open partially or fully. This region is called a ports overlapping, or during this region a process is happening. This is called a scavenging. Scavenging process is there between Cn and F. The scavenging process is the fresh charge push the exhaust gases to move push the exhaust gases to move out from the cylinder. This process is called a scavenging process. Thank you. Please like, share and subscribe. And this is my blog. Thanks for listening. Thank you.